So I'm going to be presenting the Amiga platform. We like to define it as a modular AI first for smart farming and outdoor applications. So I work as a research engineer at Bonsai Robotics. So and the talk, yes. So I'm going to divide the talk in three main parts. The first one, it's going to be a more an overview about the platform, the Amiga platform. The second one is going to be a bit more technical, so there's going to be a bit of code involved. And the last part, I'm going to give some pointers about what we do at the research team at Bonsai. So the Amiga, we started the platform. So right now, I work as Bonsai. But in practice, this platform was developed originally at FarmNG. It was the previous company. So we recently got acquired FarmNG by Bonsai. So now we operate under Bonsai, which means more resources, new models, more things in general, right? So what's the Amiga? So you can see here in the picture, it's a electric robotic tractor. We like also to call it a platform because in reality it's a platform that allow to everyone to do a lot of things, applications. So in short, so it's battery powered, it's very lightweighted. I'm gonna give some details about it. And the good part of it, as the title said, it's AI first because we can program software on top of it. So, and this, we believe that it's gonna be the big change here, how to transform the agriculture practices. So, the main capabilities of the Amiga is that, and the reason why I'm here is that we provide an open source SDK, as I said, so that anyone that purchases an Amiga, it can just develop their own solutions. I'm always asked, okay, what does the Amiga do? And the answer I usually give is that it can do so many things, as many things as you would like to do. So, and that's the reason or the result of having this open source SDK, because you can program the actual applications. So we provide with some features, but the good part of the Amiga is that you can program yourself. The other good part is that it's configurable, modular. We'll see now in short. But this means that, as you can guess from the pictures, it's a very simple structure, like 4 wheels attached to each other. But we'll see now that you can configure the tools. You can add, remove these farming tools. You can make it wider, shorter, taller. And, well, that defines pretty much the expandable item here. So to give also a bit of context, so this project started now 4 years ago, but the first milestone was in 2023. This was the original Amiga, the very simple with wheels. And then eventually we evolved, I'm going to refer later, but to add more sensors to it. So that's all the AI part involved. So now you can imagine the Amiga as a kind of Lego kit that we provide with the very basics, but you can keep adding things. And we also provide some sort of packages. The most common one for researchers, it's the one that comes with the cameras, the GPS. We have also like a remote control. So we have so many things and a whole ecosystem of accessories. So one of these potential applications that customers or researchers, they use the Amiga for in terms of farming, it's for soil preparation, planting, taking care of the crop, or just to manage some sort of disease like pests, harvesting, and packing and shipping. So those are like the most common applications on the fields. And then in terms of more details, so here you can find, for example, before I said this lightweighted, So the base weight, well, here is 320. This it's more or less 145 kilos. So the size, the ground clearance is like half meter. And you can charge that in 2 to 4 hours. The maximum speed, it's that's near like 8 kilometers an hour. So it's not a very fast device, because in farming you don't need like a fast car or a Formula One, right? So in the farm things go really slow in general. And also the Amiga can support a payload, so you can put things on top of it, and supports near, I think it's barely 300 kilos. And as I said, and that's the interesting thing, the sizes, as I said, you can make it wider. So let me show you. So here there are some screwdrivers that you can just take it out, make the Amiga wider, and the reason because of that is all the different farming fields are different. So in types of the type of terrain, and also the sizes. So that was I think a very smart movement from the very beginning, so that the platform can adapt to all the different types of crops. So now more going to the how to customize, how to make applications happen. So the good thing of the Amiga, as I said, it's from the very beginning we wanted to be the platform modular, so that you can build like the whole cycle of a project. So, and usually you can do that with the Amiga following these phases, right? You first try to understand the problem, then you make some sort of design, and then you finally build it, and then because of the nature of the Amiga, you can like produce the whole cycle of the project within the Amiga ecosystem, from the hardware and software. And I'm gonna give you here just I put here just a few examples of different projects achieved with the Amiga. So this one is, so you can see here is the regular Amiga, but in this case was adapted. I'm pretty sure it was for some kind of vineyards where there are like taller trees. So these guys here, they just adapted, they added this attachment, I guess, to add more sensors on top. And another very common case in the middle one is just to help the workers. Actually, now, just as a fun fact, Amiga, it's in Spanish, it means friend. So, and the Farm-G, it's based on California, where there are a lot of Mexican. So, and actually the workers of those fields, they put the name of the robot because they were calling, oh, here it comes Amiga, the friend, our friend. So it was meant from the very beginning to help workers. And here you can see very well. So in that case, helps the worker to release the pain of like carrying all these big boxes all the time, right? And another cool example that was very like popular in the media. So someone of their customers, they just installed in the Amiga like a flamethrower. So it was like kind of impressive to see this robot like throwing flames like in a video game. And this is all possible because the Amiga allow you that, right? To customize, remove, and add things. So now I'm gonna start moving to the interesting part, how to enable all this AI. As I mentioned, we have the base Amiga, and we have what we call the intelligence kit. And this means on top of the Amiga, you can see this screen. This screen internally, it's an NVIDIA Jetson that we created some sort of OS system where the users through the SDK, they can create their own applications. And not only that, we provide with these cameras, the OGD cameras from Luxonis, which are RGBD cameras. So these open a lot of possibilities to have also the spatial information. And in particular, these cameras also, they are very interesting because you can run on device the models. So that's a very interesting thing. In addition, this particular setup, it has like a RTK GPS, so to have a very, very precise localization in the open fields. So that's the intelligence kit. Now let's go and see how to create applications with that. Yeah. So a couple of years ago, we created what we call the Amiga development kit. In short, probably you will see there ADK, we call it. So the ADK is an open package that interfaces with the internal services of the Amiga. And what does it mean? It's a Python package that's very simple to use. I'm going to show now real code examples, and you will see how easy it is to use and integrate with libraries such as OpenCV in that case. And not only that, you can try to go to the web page. I'm not sure if it's accessible or not from here, but we have tons of information about all the components from the hardware to the software and how to use this API. You can see there is an examples tab. We have up to 15, 20 different examples that they are also open, and how to use the SDK. More information about this, as I said, this part of the software, it's open source. Well, here a typo, repeat it. The documentation is online, so it's, we try to create the information, and we have also like a good community. So we have also a forum, a discourse forum with community, mainly researchers from universities or companies doing research and development that they are using this platform. So, and they all like communicate through that platform. We have more or less constant people from the team, the software team, that try to just keep the forum alive, answering the questions. And what else? Just mentioned the API, how to use the tutorials, and yeah, the community, it's a discourse. Yeah, well, this is just screenshots of how it looks like the discourse. So I would say that every day we will receive like several messages, so it's a very healthy community. And also, this is a post that probably was the first post I made. Like, we are also sharing examples, so it's an interesting ecosystem. So now, more in particular, the different components. Probably you've seen in the picture of the Amiga. So in the Amiga, the basic one, it provides with the dashboard. So the dashboard is this this component that communicates with the low-level communications of the robot, such as the canvas responsible for the controller. And it's at some extent open. Also, we provide examples that you can just adapt. It has standards like can open. There is this graphical interface here, which I'm pretty sure that you can also like kind of customize, and it provides also updates over the air. And this is mostly like the most low-level part. I don't know if you're aware about CircuitPython. It's a very nice project from Python that you can program like really low-level things. Now, more what is the actual, like the brain using the ADK where you can run the AI. So, as I said, this is in the end NVIDIA Jetson platform with a nice Rogerized screen that it's ready to be outdoor. So, you know, I mean, in outdoor, anything can happen. Rain, dust, so this is ready to work in such conditions. And as I mentioned, we have an SDK that you can communicate. The users have SSH access, so literally, at least the research platform, we just give access to the brain. So it means that you can SSH, you can enter, you can install anything, remove, better not remove a lot of things, but you can install anything, including, I mean, I'm going to talk about this now, but most of the users, for example, they install ROS too, so that it's an easy way to communicate. But you can literally install anything on that. Then, well, I mentioned here we have ROS support, the DORA support, which is a project that I particularly worked, and I'm going to show some examples. Besides the, so the SDK, we provide very basic functionalities, how to stream the cameras, how to send controls to the robot to move around. But in the most recent stack, we provide a little bit, not that much, because we want people to build their own applications. We provide some sort of sensor navigation. It's a sensor fusion algorithm that is proprietary in that case, and we just provide like the high-level layer just to send basically waypoints. And we provide a bit of functionality for following rows and also the turnarounds. And I think in the most recent one, they added also to control like the tools. So now a quick overview. So the new stack, it's running in Rust. And all the communication is through a gRPC. And here I just wanted to illustrate a bit how is the internal architecture. It's based some sort of microservice thing, which I'm going to give details later, but we are evolving that. This is kind of the first module. There is like an Amiga service that provides a recorder, because that's another very interesting use case with a lot of users that they want just to record data for do later analytics or just train models, the researchers. And basically the Amiga research contains low-level driver access. Then we have separated the canvas for the controllers. We have like the filter, it's for the navigation. And then there are more high-level apps like the track follower, which is for a GPS path following, or for example, telemetry, system monitor. So, and all this runs in Rust, and we expose this Python API. In the end, it talks through the gRPC. The first example I want to show, I'm a computer vision guy, so obviously I would like to show how to get images and do something with cameras. So this is an example that it's public using the Python API with the gRPC. I know how much familiar you are with Python and async, so we use Python async here. But that's how it will like a very basic program to grab like image frames. So we just have some definitions. We have this event client. This is kind of the base piece of our API that we subscribe. There is a configuration. You subscribe to the camera. We don't call it topic, but it could be, if you are familiar with ROS, something similar to topic. And this will just stream messages. We use protobuf messages, which are part of the SDK. The schemas are part of there. And you know, in robotics, we like to measure things, so we also provide all the metadata, like the timestamps and different clocks, which is good also to synchronize different sensors. And as an example of an integration here, you can recognize OpenCV, right? You can see that it's easy to integrate with other libraries and then show with OpenCV, but eventually you could add here a line, for example, and call PyTorch, YOLO, and do some kind of detection, right? It's also part of the Python ecosystem. So with this example, I just wanted to show how easy it is to use the SDK and integrate with the ecosystem. Another similar example, as I said, we have 15 examples. I'm going to show you only 2. But this one is how to move the robot. Very similar. We have this event client, and then in that case, we attach to the keyboard so that we can just send signals to the controller. And you can see here, just we have a while loop just to capture the keyboard press. And then basically, here I'm just showing how to transmit the messages to the twist topic here, which basically, well, is linear velocity and angular velocities. And you see, in very few lines of code, you can move the robot. And these are just the basics to start doing applications, right? Just very few commands, just move forward, backward, just turn. And as soon as it is with the Python ecosystem, I mean, I will let you figure out what other kind of applications you can do with that. So that's the ROS bridge. We have a ROS bridge, but when I say we have, I wanted to add this here because this is kind of a successful story of part of the community. So there is a ROS bridge that we do not maintain. So it's maintained by the Merced University, their Department of Robotics. So these guys, they acquired one Amiga, and then they wanted to use ROS. At that time, we didn't have any ROS support, and they said, okay, it's open source. We're going to support that bridge. They just did it. So they took the Python SDK, and they created a couple of ROS nodes that basically translates the PharmNG SDK messages to ROS messages, and it works. And now part of the big community using ROS with the Amiga, they just use this package maintained by the university. So another example, that I was working recently is the Dora Rust. I'm pretty sure you're aware there is a workshop. Xavier is not here, but I did a collaboration with him to integrate the Dora in the Amiga in a very similar way as the ROS2 integration. So just starting from the SDK. Well, here I'm showing like the full data flow of the different like components that we created for interfacing the Amiga with Dora, but basically it's a set of Dora nodes for the camera, for the IMU, the GPS, and canvas. So basically all the low-level sensor. And here, again, I just wanted to show, it's pretty similar to the examples I showed before. You can recognize this event client, which is the basic thing for us. Based on the subscriptions, and again, using a third-party library, OpenCV, we just convert the Amiga messages to the Dora ecosystem messages, and that's a typical Dora node. So yeah, so in every loop we just grab the image from the SDK, and then with this routine to convert, we just send the message back to the Dora. So this means that if you have running this, then immediately you have access to all the different nodes available in the Dora Node Hub. So, and you know that Dora now is kind of leading the scene in models in AI for robotics. So it's really efficient way to use and use the new state-of-the-art models in that way. Okay, so that was pretty much the Amiga development kit, which is the kit for just doing the basics. As I mentioned before, now that was PharmNG, now we are Bonsai Robotics, and there is a new research support team, which I'm part of, where basically we are going to be just supporting the research with the new, let's say, trending topics, which means also that we want to provide to all the researchers a more functional kit integrating with more state-of-the-art or more successful projects. Like we want to do integrations with the Hugging Face, providing data sets, models, be integrated also with Lead Robot, which is one of the leading frameworks for robotics now, so that with the Amiga, you can directly access to that. Of course, more integrations with OpenCV, Cornea, Dora, I explained, and Xeno. I'm going to explain a bit about what's going to happen with Xeno. So that's more or less a bit the strategy we want to follow from the research side. So we're going to develop a new API based on Xeno. For those that you don't know, Xeno is a PubSub framework written in Rust, which is really simple, very low level. And we have been experimenting with that for a bit already, and we decided we want to use it because it's really simple to share the data across, to also do data recording. And as I mentioned, with the research kit, we want to enable all the researchers, Amiga users, to do like the full end-to-end, right? Which means from the recording the data, curating the data sets, fine-tuning models, and finally to deployment, but in a way, collaborative way, right? And that's why I pointed before to just uploading models, data sets to Hugging Face. This team, we are going to focus on the visual language models and visual language action models. So this is part of the future directions, already almost happening. But more in the short term, because we're building just the ground for this new research direction. So probably the first step is going to be this integration with the robot inference using Dora, so that it's more basically all the tool set needed for later work. Just an example of the type of data you can get with the Amiga that we're experimenting now. This is using Rerun, another great tool for visualizing data. So this is kind of the data we're dealing for to use for the visual language action models. In that case, we are experimenting here with an application for people follower, to follow people using these end-to-end methods. If you are familiar with computer vision, of course you could run a YOLO to detect this human here and then write yourself some sort of policy to send the controllers, but we are going to be exploring how far we can get with the visual language action models with a very simple project like this one. So, and this is just like the first, really the first project. We want, well, we are working in this direction, but in the future we want to expand more on that. So this means that we are, as you probably said, we are very open. So we're interested in collective data sets for outdoor applications. That means that if anyone is interested in that, we are very happy to talk and to put more data sets in the open through the Hugging Face ecosystem to help with improving the foundational robotics models. It's another thing that it's directly correlated with the visual language action models experiments we're doing. And I hope in the future, based on that, we can organize or participate in workshops, hackathon, courseware. I'm throwing here the hand to Satya, which I'm pretty sure it's going to be very related to him. And then, yeah, we are happy or to collaborate with the sponsors for open source development for robotics.